think you have to kick it off.
Well, we have a couple minutes. Yes, right? Hey, Eric, can you tell the rest of the board to get in here?
So if I sit and join you? I think you just click that one on.
So I'm just kind of waiting till my board members get in here so I can introduce them. All right, so we're down one. But anyway, should I go ahead and get started? Is that okay with everybody back there? Okay. So I'm Cindy Hahn, and I'm president and founder of the Alagille Syndrome Alliance. And I'd really like to welcome all of you here tonight. This is our 6th International Symposium on Alagille Syndrome. And we are just so excited to have everyone here tonight and for the weekend. I will give a little presentation first thing in the morning when we get started, but I did want to tonight just kind of point out my trustee board of directors who are all standing back there in the back of the room, and they've been scurrying around all day to get everything set up for tonight. So from the left, my daughter's kind of standing there in the doorway too. She's not on the board, but that's my daughter Elena. And then we have Eric Luxhoy, who is our IT guy and webmaster. Joe Anderson, who is, you probably see him a lot on Facebook. He's our social media guy. Anna Chow, who has done just a little bit of everything for tonight. She's largely responsible for the goodie bags that your kids got. So we thank her for that. And then Patty Everett, who is our trustee treasurer and keeps care of all things money related. Wanda Shepard, who took care of securing the venue and working with the hotel to get everything in order for tonight. And all right, who are we missing, guys? Roberta, where's Roberta? And Bill. So I'm not sure where Roberta is. Roberta Smith. And then we have Bill Glenn, who's at the table right there. Wave, there you go. Yes, he put together our program for this weekend. So we're very thankful for that. Yeah. A couple of things about our agenda tonight. So we have a presentation by Dr. David Piccoli as an introduction to AGS, or ALGS. I keep forgetting to add the L. And then we will have Avril Shurker from NIDDK, who will be talking about research at the National Institutes of Health. And then from 8:30 to 9, we're going to do a Angels celebration of life. So to remember those of our loved ones who have passed away as a result of Alagille syndrome, and we'll be doing that out on the patio right out here outside the door. So we invite you all to come and share in that. And then from 9 to 11, we do a thing just called Chill and Chat, which is, it's really informal. We don't have any scheduled rooms or anything for it, but we encourage you to just meet some new people, sit around, talk about Alagille syndrome, and share experiences. So without further ado, I wanted to introduce Dr. David Piccoli. He is chief of the Division of Gastroenterology, Hepatology, and Nutrition at the Children's Hospital of Philadelphia. Graduate of Johns Hopkins University and Harvard Medical School. He was a resident from 1979 to 82 and chief resident in pediatrics from 82 to 83 at Children's Hospital, Boston. He completed his clinical and research fellowship in gastroenterology and nutrition at the Children's Hospital of Philadelphia from 1983 to 1986. And he is director of the Fred and Suzanne Biesecker Pediatric Liver Center and holds the Biesecker professorship and endowed chair in pediatrics at CHOP and the Perelman School of Medicine at the University of Pennsylvania. Gosh, I am having a hard time tonight. Dr. Piccoli has been the Associate Chair for Information at the Department of Pediatrics at CHOP since 1996. And during his tenure as chief, the division has nearly tripled in size and has vastly expanded its clinical and research mission in gastrointestinal and nutritional disorders. And at the same time, the division has trained 100 fellows. His main interest areas of clinical and research are metabolic and genetic liver disease and inflammatory bowel diseases. And he is a member of the group that discovered both Jagged 1 and Notch 2 as the primary causes of Alagille syndrome. And we are incredibly thankful to have you here tonight and that you love our disease as much as we do.
Thank you, Cindy. Thank you. I'm going to see if I can turn this on. I may need Eric's help on this. Eric, did Eric step out? Oh, there it is. Oh, no. As long as we're filming, it would be probably better if I wasn't facing this way the whole time. So, all right, I'm thrilled to be here, and I would like to echo the thanks to everyone who organized this, Cindy and the board of directors, everybody who put in the time, the NIH leaders who are here today. And my goal with this talk is to sort of kick things off and to overview almost everything without going into too much detail into anything. Some of you have been to, maybe if we could have a show of hands, how many people have been to more than 3 symposia, local or national? 2? So there's some people who are pretty familiar with things. For other people, who's at one of these for the first time? Good. Okay, so I have some very introductory slides, so it looks like that will work out pretty well. So a reasonable question for this group is, what is Alagille syndrome? And I think all of you know that this is a disease that, because most of us who have studied this for a long time are liver doctors, we like to say that this is a liver disease characterized by a lack of the bile ducts that drain the liver, associated with a whole bunch of other things, which include a particular or characteristic facial configuration, heart disease or a murmur, bone, eye, kidney, vascular, and other abnormalities. And when these things all come together, which they don't always, we call that a syndrome. And to jump to the answer at the end, what causes Alagille syndrome, we know now that essentially all Alagille syndrome is either caused by mutations in a gene called Jagged 1 or in a very small percentage in a gene Notch 2. And then there's still a few patients in whom we can't find a genetic cause yet, but overwhelmingly these are the causes of Alagille syndrome. So I'm going to spend just a minute talking about the functions of the liver so that everybody's sort of up to speed on that. The liver is really the most exciting organ in the body, and it really does an incredible number of essential functions. It makes proteins for export, including things that do clotting. It makes albumin, which is essential for our vascular system. It purifies and detoxifies a number of chemicals. It gets rid of bilirubin. So if it can't do that, that causes jaundice. But it also metabolizes a huge number of drugs, takes care of some metals, some toxins. And although most people don't think of the liver as an excretory organ, we think of the kidneys as the way that we get rid of things. Actually, the liver is also an excretory organ, and it's that inability to excrete bile and toxins and other things that is really a hallmark of Alagille syndrome. And then the liver is also a big regulator for everything else in the body. So I just wanted to show for a minute the structure of the liver. And so these are liver, you can see on the arrow, these are plates of liver cells, and these are arranged in a very specific way. And then there's a very large vascular system, a blood supply of arteries and veins. And then these pipes here that are in green are the bile ducts. And they essentially drain through very fine channels. Every single liver cell drains into larger and larger channels and out into a single common bile duct, which then empties into the duodenum, into the bowel. And it's a problem with these ducts that is the issue in Alagille syndrome. So this is the picture of what a pathologist looks like. How many here or their children have had a liver biopsy? You know, if you take the older patients, everyone had a liver biopsy because we required it. How many people here have never had a liver biopsy but have a diagnosis? And that's more and more common now because the genetics are so good that coupled with the clinical picture, we don't necessarily have to go and do a biopsy. But the pathologists see this picture. This is a cartoon, not a real histology. But what you typically see in the liver is you see arteries, veins, and ducts. And when you don't have the proportionate number of ducts in that liver, in these cross-sectional slices, you have what's called paucity, a lack of ducts, and that is the hallmark of Alagille syndrome. So bile duct paucity is defined by the pathologist, not by anyone else, as having too few ducts per portal tract. And while that's very helpful, we also know that in young infants, which is when many people have their diagnosis made, that this ratio hasn't yet evolved, it hasn't occurred, and so many times we're actually misled by an early biopsy where there seem to be enough ducts and people think, okay, so maybe this isn't Alagille syndrome, or sometimes they even make the decision that this might be biliary atresia, which for those of you who had the diagnosis made in the first few months of life, probably people were thinking biliary atresia being much more common than Alagille syndrome might be what your child has. So this is a real picture of a portal tract, and what you're looking at here, the very thin-walled things are veins, the thick-walled things are arteries, and this is a triad or a portal tract, and it just doesn't have any bile ducts at all. And this is Daniel Alagille, who was a French hepatologist who first described this. He recognized this in the 60s. The first paper in English, which is a landmark paper, was in the 70s. Some other people also described the syndrome by a different name. And so in the beginning, it had a number of different names. None of them were Alagille syndrome. And then over time, we've come to name this after him because he really did tremendous early work on defining the syndrome. And pretty much if you go back to his paper from the 70s, pretty much everything he said is exactly right. So how common is Alagille syndrome? You'll see a bunch of different numbers, but I'm going to show you a little bit of data later. It's about 1 in 30,000. So in all likelihood, your family is the only family your pediatrician has ever seen or heard of with this, and sometimes the only family that your pediatric gastroenterologist follows with this. It's a very rare disorder, And in this group of things that are listed here of neonatal liver disease, you can see that it's one of the more common things of an incredibly rare group of disorders. So what's the typical scenario for diagnosis? And I would imagine that most families in this room follow this, but then there are some people who have Alagille syndrome diagnosed in the teenage years for something else, for a totally different organ system, or diagnosed because they're a parent of a child who's diagnosed with Alagille syndrome. But a typical scenario is to have heart disease that could be severe, or it could just be a murmur that's barely audible, neonatal hepatitis or jaundice, sometimes poor growth, sometimes other problems in other organ systems, sometimes neonatal kidney failure, things like that. And then the typical labs that we see with bilirubin and liver enzymes and duct enzymes, and we'll talk a little bit about those. So how do we typically make this diagnosis in this group of infants and toddlers? No single test really makes this diagnosis unless you go straight to genetic testing, which of course is not the way we usually go through this. You get some blood work and it says that the liver is inflamed or it's backed up, an ultrasound, and sometimes the ultrasound can see a gallbladder, sometimes it can't in this. And then many people have a decidus scan, an excretion nuclear scan, and then for the longest time, always a biopsy. Now that's not always true. And testing for mutations, when we had the first International Alagille Alliance Symposium in Milwaukee, Oregon, most people told the story that they sent their genetics off and they would get them back in 5 years. Actually, in the beginning, you never got it back because it hadn't really been discovered. And we were kind of proud in Dr. Spinner's lab that maybe in a year or so, maybe a little bit more, we could get something back to you. Now the genetic testing is available on a non-research basis in many labs across the country, and it comes back very quickly. And so commonly, we're sending the genetic testing off on the second day that we see a baby with the problem and getting it back pretty quickly. So that part has really changed dramatically. Well, how is this syndrome defined? Alagille himself actually defined it as having the bile duct paucity and then at least 3 of 5 clinical criteria, which in his mind were a characteristic face, a heart murmur, butterfly vertebrae, this little eye-finding embryotoxin, and some kind of backup in the liver. But then there clearly are people who only had 2 features or 1 feature or 1 feature that was dramatic in a different organ system. And now we know that people carry the risk for Alagille syndrome and the risk for transmitting it if they have a mutation, even if they don't have any features at all. And there are some people who don't have any features at all, but who could have a child or a sibling or a parent who's severely affected. So I'm going to define a couple of terms. The first is cholestasis, and you saw on the other slide, neonatal cholestasis is this picture of jaundice in a newborn. Cholestasis means lack of bile flow. And what's important about bile is that it is the flusher or the excretion fluid for a number of things that the body doesn't want. And that includes bile acids. And bile acids, although we need to get rid of them, we use them for digestion and we reabsorb them, but they have to come out of the liver. Bilirubin, which is a breakdown of blood, we don't need that anymore at all. Cholesterol is actually excreted in the biliary system, and then a number of drugs and toxins and other important things, metals and so on. The word jaundice to us is a little bit different. It means yellowing of the eyes or the skin, and that's due to bilirubin buildup. And while bilirubin and bile salts have some similarities, they're actually very different in what they are, what they do, and how the body handles them. But they both get backed up along with cholesterol if you don't have the plumbing to drain these from out of the liver. So Cholestasis, lack of bile flow, leads to a number of problems, but the one that we can see visually are xanthomas. And so many of you have seen these directly. These are lipid-filled or cholesterol-filled deposits in the skin. And you see them here, hands, feet, in creases, ears, sometimes nose. Sometimes they're very mild. Sometimes they don't happen at all. And sometimes they can be very disfiguring or even painful. So this cholestasis in the early articles was felt to be present in 95% of people. And these are the things, and I've just listed them. I think you'll get a little flash drive of all of these slides. But these are the things that we look at when we think about cholestasis. And there'll be a talk tomorrow on cholestasis and how we deal with it. A second feature that Alagille recognized were a characteristic facies. And what has been recognized over time is that this childhood, a little bit more triangular, prominent forehead face, actually matures and changes into adulthood. And the features are very different. And one of the studies that Dr. Krantz did, when he showed pediatric facies pictures to geneticists, they were very good at this. When he showed the adult facies, they were terrible at it. And these were people who did or didn't have a diagnosis, but who carried a mutation. So a third organ system that's affected is bones. And the typical feature that Alagille recognized was this butterfly vertebrae. So this is someone who gave me their really spectacularly beautiful scan. This is a nearly normal vertebral body. Here's one with irregularities. Here's one with a little bit of a cleft. And this one is a full butterfly. And it doesn't look like this on a CAT scan or an MR, but when you look at it on a chest X-ray, these should be straight across and flat, and it kind of looks like butterfly wings, something you see in Alagille syndrome, but in a lot of other diseases as well. So there were a large number of eye findings, and Alagille recognized these. The most important diagnostic one of these is posterior embryotoxin, which is this line that we see right there, really right at the edge of the iris. For most people, it means absolutely nothing, except it's important for diagnosis. But there are a number of other eye findings, some of which are due to things like vitamin deficiencies and so on, which 20 or 30 years ago were really quite terrible, but now we have great vitamin preparations and other things, the ability to watch levels, and so some of those things we really don't see much of anymore. So the heart disease is really very important, and for some patients it's everything, because some of the heart disease in Alagille syndrome is really critical malformations, and in the vast majority of people it's a little murmur that is out in the peripheral pulmonary arteries. And so we hear this with a stethoscope, but for the most part, it doesn't matter for most patients. But these disorders like tetralogy of Fallot and VSD, these are much more important, and these are things that are dramatically evident right at birth, and now more and more commonly evident by ultrasound, by fetal ultrasound, commonly months before birth. But sometimes patients with Alagille syndrome go to the cardiologist first, and the gastroenterologist gets left out of the picture for a while. So there were a number of centers that started to study Alagille syndrome. Alagille's group first, and then a group in England at King's College, and then several places in the States became interested. And the studies that are commonly published about how many people have manifestations, these are some of those studies. We required patients to have at least 3 features in order to say that they had Alagille syndrome. So the number of features per patient is obviously very high. So this turns out to be extremely misleading science, even though this details hundreds of patients, because in fact what we recognize now is that there are many people who carry the mutation who are barely affected at all, and I'll show you some of that. So other features, and we'll have some sessions on some of these: kidney disease, blood vessel disease, strokes, intracranial bleeding, other types of bleeding in other sites. Nutrition is obviously a major part of things, and bone disease and fractures. This is a picture of some of the major blood vessels on the arterial side that have been shown to be abnormal in some patients with Alagille syndrome. Important to know about them and to watch for them. Sometimes these things can be taken care of in nice ways if they're detected early. Some of them, as you'll hear about tomorrow, are in the blood vessels that go to the brain, and that's obviously a very special circumstance. Other things that people sometimes ask, and this is data, and again, it'll be on your flash drive, but what's the percentage of patients that go on to transplant or to have bleeding or so on? Each of these numbers is based only on the patients who are most severely affected. So again, now that we've moved into a newer molecular age, all of these numbers you would expect to be significantly lower than these older studies that talk about these complications. So this is one of those older studies, and it hurts me a little bit to say now this really pretty old study because I felt young at the time, and so time marches on. But this is data from CHOP, from Children's Hospital of Philadelphia, and also from Alagille's group. And what you're looking at here is the number of people who survive over time with and without transplant. And compared to many neonatal pediatric liver diseases, this was, at the time, pretty good. But now we do much better than this in a couple of ways. Not to mention, we should mention, that transplant now, liver transplant, is an extraordinarily good, successful therapy where we really expect very high percentage, excellent quality of life. Some of these patients go back 40 years ago when you didn't even have an option for transplant. The one thing that is most important for survival is the heart that you're born with. And so if you have that tetralogy of Fallot or tetralogy with a pulmonary atresia lacking one of the very big vessels, that's really very severe, and for many years we didn't really have any therapy for that at all. Now the cardiac surgeons are able to build conduits and baffles and other things to really do some incredible things with these kinds of hearts, but this plumbing in the heart is the single most important determinant of mortality in Alagille syndrome. One thing that many of you may know is that for many children with Alagille syndrome, there is a peak of cholestasis, and then they get better. So there are many people who had a lot of xanthomas, and they're gone, terrible itching, and it's gone. And so sometimes we're trying to bridge therapy to try to get to that point where things will get better. Other times we have to go on a different course and either do diversion or transplant, depending on what's going on. But this is different than almost every other pediatric liver disease, like biliary atresia. If you had those same numbers at age 1 or 2, you would be 100% transplant. But in Alagille syndrome, it's much harder to predict the future. So how is this treated? And there'll be more time spent on this throughout the weekend. But we try to support the liver by treating with vitamins and extra nutrition. We work very hard on the itching. Nutrition really is a key part, particularly early on. And then we have different therapies for other complications of liver disease and different kinds of surgery for things like itching, and ultimately transplant for liver failure or failure of the other therapies. So what signifies a failure of therapy? Well, the most important one is when the liver cannot do its basic functions and it can't support good quality life and growth. That's a failure where you have to do something significant or trade out the liver for a transplant. You also a smaller percentage of people, but it's very severe if it happens, build portal hypertension, where the blood flow into the liver gets backed up and the spleen gets very enlarged, and sometimes they bleed into their esophagus or their stomach. So that can be a very severe complication. Sometimes we deal with it locally, but sometimes you have to do a transplant in that scenario. Failure to grow and other complications, pruritus that you just can't get under control, bone fractures that you just can't get under control, other things, or other reasons why someone might end up, for failure of the liver, end up getting a transplant. So we talk about synthetic liver failure. We said in the beginning that the liver makes different things, and the most important things are clotting proteins, albumin, and those are things that you have watched every time when you get laboratory studies that we're looking at to see how the liver is doing. And there are many times in Alagille syndrome where the synthetic function is good, but the excretion function, getting rid of toxins and bilirubin, is terrible. So we said what portal hypertension was. It's that big spleen, and that's something that we watch carefully. There are some people who have humongous spleens and never have a problem, and there are some people whose spleen is only moderately enlarged and can have a bleed, and we don't have a particularly good way in children of predicting which child will fall into which category. So what about transplant? And I won't say much because there'll be a transplant talk, but if you look at these numbers, you see biliary atresia is far and away the most common indication for pediatric liver transplant, and Alagille syndrome is way down here. The vast majority do not end up needing a transplant. Transplant in Alagille syndrome is a little bit more complicated, and this is one paper. Because it's a genetic disorder and it's dominant, there have been some occasional times where a parent has gone to give a section of a liver to their child, and at the time of that operation been found to have asymptomatic, symptom-free Alagille syndrome, but the ducts were no good and they couldn't use the donor liver in the child. So it's a little bit different, and now that genetic testing is so easy, we don't recommend all of this complicated liver biopsy and everything, just to do the genetics. So we're going to move a little bit to the genetics, and we have some of Dr. Spinner's lab is here representing her as far away from the podium as they could be. The first clues to this being genetic, Alagille recognized this. He knew that this happened in families, and he recognized that it was probably autosomal dominant. But in the 1980s, with techniques that we now consider very much the dark ages, there were a few patients who were recognized to have deletions of a band, a little missing segment, and they also had Alagille syndrome. And this gave a clue about genetically where this gene might be sitting. And as you know, this is on chromosome 20. And this is a moderately, significantly more modern technique to look at this. And you can see that with the markers, you're missing one of these jagged genes. And having it missing or broken is what leads to Alagille syndrome. So in our own group, we started, Dr. Spinner and I met in 1992, and we agreed that we would take this on as one of our missions. And this was actually a family from very close to us, locally in Philadelphia. And as we started to do that kind of genetic testing back then, we found that there was a translocation, which means that a chromosome broke and it reconnected to something else. And that is something that is extremely helpful, or at least was back then, in helping to identify where a gene might be. I leave this slide in because this represents years and years and tears and fears, and we're going to ignore it. This is horse and buggy, but this is what we did for a very long time, and many people here gave blood for those early studies. And then in 1997, Dr. Spinner's lab, in 2 different collaborations using 2 different sets of patients, identified that jagged 1 was the cause of Alagille syndrome. And back then, if you could show this in 4 patients, this was kind of like a landmark sort of thing. And what was surprising to us was that one other disease that CHOP had been very involved in researching also had similar features to Alagille syndrome in that it had heart and embryo toxin and spine and other things that sounded kind of similar. And it was actually due to a whole bunch of genes that were contiguous that all dropped out. And so Dr. Spinner's lab all the time in the beginning was thinking this would be a whole bunch of genes tied together, and that's why some people would have a heart, and some people would be liver, and some people would be kidney, and that made sense. And of course, it was totally wrong, because what this gene turned out to be was a very large gene that's been present since early on in evolution. It had been well studied. It's a 100 years old study in fruit flies, but we had no idea what it was doing in humans. It turns out that mice use it for a little bit, and we think that, as mammals, we're fairly closely related to them. Fruit flies use it for something different. Worms use it for something different. But in humans, this notch signaling pathway is involved in the embryologic development of most of the organs in humans. So we kind of honestly foundered into this. We were thinking that it was something else was going on, and I'll show you some studies that sort of show how this gene is active in many different systems. So this slide is pretty much the current state of things. We know it's dominantly inherited. You only need 1 broken gene. We know where it is. The testing is really easy to get now and pretty cheap. Some people have a deletion of the entire gene. Some people just have a single letter in a single word in the encyclopedia that's been changed. One of the important things that we never really had a good handle on was when we see a child, how often will we see the gene mutation in a parent? Now we know that that's about 60% of the time it's new in the child. All of us have some mutation that our parents didn't carry, but most of them are silent. If you have a mutation that your parents don't carry that's in a very important gene or a dominant gene, that can cause disease, and that's what's happening here. So we don't expect that a parent will have to have this. It's a little bit less than half the time, but obviously most parents are really clinically fairly well. Sometimes it's a surprise when you go back genetically, and I'll show you some of that. So this is this notch signaling pathway, and in fruit flies, it causes notches in the wing. I spend a lot of time with geneticists. I don't claim to be one. I love the way they name things. This is the notch, but this system is really incredible, and it's one cell that expresses JAG1 or another thing that is like that, sort of a key, and the cell next to it expresses one of the notches, which is kind of like the lock. These two bind to each other. Something cleaves, something moves, something talks, something changes what happens in the nucleus, and then more or less, this cell sort of talks to this cell and helps this cell to decide what it can become. And obviously, becoming something like a bile duct is a good thing, and if that is broken in some way, that can lead to defects, and it does actually lead to defects in many different organs. So it turns out that jagged and notch for us have really been a window on human embryologic development. And I'm just going to show very briefly, this is a study by Dr. Looms, who sends her apologies. Gold here means that the gene is expressed, and you can see kidney, heart, spinal column. You can see that this gene is active there. This is from Dr. Rand in our group, looking at ducts, and the gold there shows that it's active in ducts. This is from Alagille's group, which shows that it's in the blood vessels in the liver. They're shown here in white. And this is in the arteries in the liver. And as you go, eye, spine, other places, this gene is just very involved in human embryologic development, first trimester things, later things. And so it turns out to be very active. We just use it in a much more important way than almost any other species. So this slide is just an example, a shout out to the cardiologist. This is a patient that we saw, our cardiologist saw, who did not apparently have Alagille syndrome. But if you understand x-rays, there are some wires here, so there have been surgery. There are narrowings all over the place, which is peripheral pulmonic artery stenosis, and there's a butterfly vertebrae. This turned out to be a patient who didn't seem to fit at all Alagille syndrome, but actually had a full deletion of the gene. So now we go moving fast forward, over the last almost 15 years. We have a very good understanding of the types of mutations and a little bit better understanding of what they do. But I think the most important thing about this for families is that now we can be very specific about who carries the risk, and we can also be very specific if you're interested in things like genetic counseling and family planning. And while our group doesn't actually do this, we provide tools that allow people to do this if that's something that fits in with their plans. So mutation testing, I'm not advertising any individual company. Many of you had things done by one group, and there's many times in the past mutation testing was done by a research lab, commonly Dr. Spinner's lab, and then sometimes we tell the commercial companies what the mutation is, and then they do it in a clinical lab, and this conforms with all of the newer and important regulations about how gene testing is done. But there are a number of places where you can now get this done, and it's essentially covered by insurance companies pretty much everywhere. Research testing is a little bit different, and there'll be some research talks tomorrow morning. When you sign for a research a consent form, you can't necessarily get all of the information specifically about what comes out. You may see it published in aggregate. So I'm just going to spend a minute on a couple of what I think are sort of interesting studies. So one of the things that Dr. Kamath and Dr. Spinner did was they looked at relatives of the people who were diagnosed with Alagille syndrome. And what they didn't want to look at was the person who was first noticed to be affected. They wanted to look at the other people in the family who were carrying a mutation. And so they found 53 people in 34 families who were not the proband, not the first person. And what they did was they looked at these other people and proved what we had suspected for a long time, which is that of people who carry the mutation, there are a moderate number who also have something that looks like Alagille syndrome. You have two children and they both have Alagille syndrome. But there are people who carry the mutation who have absolutely nothing, or have one or two very minor things, or sometimes three features, but these might be a butterfly vertebrae and an eye finding and maybe a little murmur, none of which ever would cause any physician to think about Alagille syndrome. So what was recognized was that the spectrum of what this mutation causes is actually very broad. It's very different from what we all had believed and published years ago. So these conclusions that we made from these studies, that when you look at family members, liver disease is much less. Some of these are just cardiac disease. Some people are really barely affected at all. And yet we have this argument sometimes, if you carry the mutation, do you really have this syndrome if you're not affected? Because a syndrome means you have manifestations. And this is what keeps geneticists, excited late at night. Again, I'm not a geneticist. I'm sure I'll get chastised on Monday. It's very complex now. And we have families where one child had severe heart disease, one liver disease and liver transplant, one kidney disease and kidney transplant, one with the mutation and totally fine, all in the same family, all having the same mutation. So what's going on there? And this is a lot of what Dr. Spinner's lab is looking at right now, with great support from the NIH, I should say, looking at what are the modifying genes. Are there other things that might cause the patients to have this kind of presentation or this? And it was this sort of thinking that led us to sort of characterize what kind of mutations cause Alagille syndrome. So this is from 247 families, and by exhaustively going through old-fashioned mutation analysis, which sometimes is 6 months per specimen, found mutations in most of the patients, but there were still a few patients who had no mutation that could be identified, but the clinicians went back and said, this really is Alagille syndrome. Why can't you find a mutation? And so what about that group? And this is one family that was local to Philadelphia, where clearly the child and his mother both had something that was, we thought, absolutely typical Alagille syndrome. This is another family that's local to us. And what we were able to show, again, in Dr. Spinner's lab, was that, well, if you make Alagille syndrome in a mouse, you can't make it with jagged 1 only. You have to make it with jagged 1, the key, and notch 2, the lock, and you have to breed them together. And that makes Alagille syndrome in a mouse. So it made sense, maybe some patients who seem to have Alagille syndrome might have notch 2 defects. And in fact, that turned out to be true. So defects in notch 2 cause a very small percentage of Alagille syndrome. And then what has happened over time now is that we've recognized that all of these different notches and all of these different jagged or jagged-like ligands are becoming associated with human diseases. And it's fascinating to us that Alagille syndrome with jagged 1 seems to have a manifestation in each of these different organ systems, brain, spine, eye, heart, liver, kidney, and so on. But some of these other diseases are just heart disease, or just bone disease, or deafness with an eye finding. And it turns out that this whole regulatory pathway that we call notch signaling is just critically important for everything, and each organ seems to use different parts of this system in slightly different ways. So these are some of the diseases that have now been discovered. And there's actually a very unusual disease in notch 2 that looks nothing like Alagille syndrome, but it's on kind of the other half of the gene. And it's regulating things, but again, facies and other things in a very different way. So what has the gene testing really told us about Alagille syndrome? Well, let's see how well we're, I don't see anyone falling asleep from dinner. So does everyone with Alagille syndrome have a mutation in jagged 1? No. Does everyone with a mutation in jagged 1 have Alagille syndrome? No. Does my child have a new mutation, or do I have the mutation? We can now tell that in each family. Does everyone have the same mutation? The truth of the matter is almost no one has the same mutation as any other family. If you have 4 people in your family with it, they all have the same mutation. But from family to family, that's why gene testing was so impossible in the beginning. There's another, we would say, easy liver disease of infants that causes neonatal cholestasis, alpha-1 antitrypsin deficiency. And because it is just this, everything is in kind of the same bucket. It's very easy to make the diagnosis. We don't even use genetic testing. We use something simpler. But in Alagille syndrome, almost all of the mutations are different from one family to the next. What range of disease does a mutation in JAGAD1 cause? We talked about it. Any organ system can be severely affected in isolation or in varying combinations. Why is it dominantly inherited? Because you need 2 of these to be talking in every cell during development. And if you only have one, the talk is erratic and incorrect. Should you be tested for a mutation? It's a personal decision. For some people who are older and who are fine, they may not want to know. For other people, it's critically important in a number of different things, including things like if you're going to be an organ donor, as we said, or for family planning and so on. So that's the question, what good will it do? The one thing that it has done for those who have participated in all these studies is it's really clarified what the syndrome is and what is happening at the cellular level. Is gene therapy coming soon? So we're not there in this disease because many of the things, the gene is active as when you're a fetus or an early infant, and it's done something to plumbing, and you could put the gene back into that plumbing, but you can't change the plumbing. If you have a hole in your heart or if you're missing ducts in your liver, putting the gene back in will not work. There are many other liver diseases where gene therapy is definitely a possibility in the near future. So we've learned a lot of lessons about this. It turns out that the Alagille basic research has told us an awful lot about embryologic development, how humans develop in different organ systems. And there are things now happening in the lab that will be very important. Also, this jagged and notch pathway is involved in a number of other things, including things like cancer and other things where the amount of research in this area has really exploded. It's interesting that every different species uses this system, but we seem to use it in a much more striking and dramatic way. And we're all convinced that there are many, many people who have minor jagged or notch mutations where they haven't been linked up yet with the genetics. We're expanding this phenotype, expanding the picture of what kinds of things mutations in jagged cause. Right now, most of the mutations we find really do significant damage to the gene and the protein. We think there are a lot more minor mutations that do something, but we don't find those patients yet. So will this recur in my next child? That's where you go to the genetics. That's a very important question, and you should definitely have a genetic counselor talk with you, as well as your gastroenterologist or hepatologist. But now we can be very precise. 15 years ago, we couldn't. Did you do anything to cause it? Absolutely not. It's not from drinking. It's not from hitting the brakes too fast in the car, any of those sort of things. These are events that happen when our chromosomes replicate, and there's nothing really that you can do to sort of make this occur. So what can you do to help? I think one of the things, you're here, learn what you can about Alagille syndrome, join the Alliance, American Liver Foundation, all the other groups. Write to the NIH, tell them you love them because they're supporting most of this research. At the local level, there are things you can do for your local centers, for raising funds, for research and support and education. The Alliance certainly is a laudable and exemplary foundation, and I will show you in 3 slides that. But I thought this was interesting. I was trying to sort of clean up my office. I have to say, one time, one of my patients took several, how many, rolls of toilet paper while I was out on the floor. And he was happy he was being discharged and toilet papered my entire office. I should have brought a slide, actually, of it. I'm trying to go paperless. So I'm trying to get all of these articles digital now rather than in all my file cabinets. I thought this was great. So you can see the years down at the bottom. This is research where the key word is either arteriohepatic dysplasia, which they used to call it, or syndromic bile duct paucity, or Alagille syndrome. But these are all human research papers, and you can see just a vast explosion of papers that are, advancing the science and the understanding around Alagille syndrome. And while this is extraordinary, I think this slide is those same papers on Alagille syndrome in these little white bars down here at the bottom. But now these are the papers coming out on jagged and notch. And so you're talking about in the range of 1,400 papers per year looking at this system. So sometimes we think in isolation about Alagille syndrome, but actually all of the science around this, and much of it will support care and other things in Alagille syndrome, absolutely dwarfs the papers that are actually on Alagille syndrome, which is still quite a good number. So I just have a couple of slides here. There are places set up where you can read other things about this, including sites set up by the NIH. There are reviews. There are places where you can look on the web to find out who's doing molecular testing. This is a place where we send a lot of undiagnosed neonatal cases because they do a number of different gene tests on the same chip. It's really amazing compared to what we did just a few years ago. And then I have to just introduce this because I think this is just the most spectacular thing. The first two times that we met, there was an occasional group here and there doing research on Alagille syndrome, but the NIH has funded a consortium, and you're going to hear about this in a minute, where centers across not just the country, but Canada, a little bit of England, we are international, really a major consortium. You can't do good research on really rare diseases at any one center. You need a lot of centers and a lot of money, and the NIH has really very generously funded this now for a dozen, and now going into the future again years, and you'll hear about this, but this really has been important for so many of the studies that you've seen before. And finally, I have to say that for many years for CLIC and children, the exemplary and leader patient support group was Cindy Hahn and the Alagille Syndrome Alliance, and that's on their website. But Cindy put in a good 10 years in addition to everything else that she's done, and definitely deserves a great round of applause from all of us. Skip that. This is from one of the symposia. I just also have to say at our center at CHOP, Nancy Spinner, Ian Krantz, Kathy Looms, Liz Rand, a number of people really have dedicated literally decades to this, but we have a whole group of people, Benita Kamath, a whole group of people who have been involved not just in the research side, but the clinical care, including we've been able to convince cardiology, endocrinology, neuro, ortho, kidney, ophthalmology and pathology all to take a special interest in this, which is very helpful to us and our patients. And then this is that liver center that is dedicated to pediatric liver disease, and the different senior faculty members in our group who have labs and do clinical studies in that. So with that, I will end. Hopefully this was a good introduction to things. I think if there's anything I really did not explain well, we can, if it's a general question, we can address it. But I think it would also be extremely exciting to introduce Dr. Sharker and Dr. Du and hear about the NIH and what they have done for children with liver disease, and specifically in this room, Alagille syndrome.
gotta touch it. He serves as the scientific advisor on research activities relating to viral hepatitis and liver diseases, and provides scientific guidance to the Division of Digestive Diseases and Nutrition as it focuses and accelerates research on liver disease at the NIDDK. Dr. Shurker also helps the division coordinate and stimulate liver-related research across the NIH and within other federal agencies. He provides scientific guidance on basic and clinical liver research, as well as the epidemiology of liver disease. His portfolio includes adults and children living He also oversees a portfolio of grants in autoimmune liver disease, liver transplantation, liver cancer, and cholestasis and biliary disease. He is a member of the Trans NIH Working Group for Extramural Undiagnosed Disease Program, the Trans Primary Mitochondrial Disease Working Group, and the Trans NIH Committee on Viral.
Thanks, Cindy. My buddy Ed Dew is at the back of the room, and basically we're a team. So everything that I'm involved with, Ed's involved with, and we're very much interchangeable. So I'm giving not David's talk. I'm going to give my talk if I can find it. It's already open. Perfect. Okay, good. So I'd like to thank Cindy and Bill for inviting us. I'm really very impressed by the turnout here and the enthusiasm, and I think you guys are in for a very good meeting. What Cindy's asked us to talk about is the commitment of the NIH to research in liver disease, pediatric liver disease, and most specifically in Alagille syndrome. And what I've got here is evidence that the NIH has been interested in Alagille syndrome for a very long time, certainly almost from the beginning of the genetic era. And this is one of the papers that David had mentioned, published in Nature Genetics in 1997, where the jagged 1 gene association with Alagille syndrome was first recognized, and the corresponding author here is a guy named Francis Collins, who subsequently went on to coordinate the Human Genome Project and is currently my big boss as the director of the NIH. The NIH, which is the National Institutes with an S of Health, is really made up of 27 different institutes and centers, 21 institutes, and they're listed here. And you probably can't see these very well from beyond the middle of the room. But each of these institutes has a particular interest or organ or disease specificity. National Cancer Institute, the Eye Institute, Heart, Lung, Blood, etc. down the line. I and Ed work in the NIDDK, which is the National Institute for Diabetes, Digestive, and Kidney Diseases, and we also throw in some hematology as well, but they don't make it into the initials. The NIDDK is involved in a number of areas. We're involved to a large extent in basic research. A lot of the research that Dr. Piccoli discussed is funded by the NIH, as well as other funding organizations, private groups, other international foundations. But the NIH is a very major player and funder of research in this country. We're involved in performing and participating in large clinical studies and clinical trials. We have programs, program grants, such as the one at CHOP. We have research core centers, which basically provide a service, say genetics or something like that, for a large group of research programs. We have infrastructure, including, very importantly, a repository where samples are kept and can subsequently be tested or used in gene discovery or various other endeavors. We're very heavily involved in research training and in career development. We do scientific workshops. We do strategic planning. We're advisory to a number of other federal agencies. And we're also very involved in public education through our website and other areas. The repository, as I mentioned, is a huge warehouse of both samples and data, which can be accessed by any researcher with a legitimate research interest, and can provide invaluable samples and the data to correlate with it to facilitate many important discoveries. And this is really one of the greatest benefits that we provide through our funding of networks such as Children, which I'm going to talk about in a bit. We really do have a cradle-to-grave support for academic research from the medical student and even pre-medical student level to postgraduate training, postdoctoral training, junior faculty, and then funding of senior investigators through a whole variety of projects here, or through a whole variety of programs. Obviously, it's important that we maintain the junior parts of this so that we have people that are going to continue to do important research going forward. Unfortunately, this is reality, and the blue bars are absolute dollars, and the orange bars are dollars adjusted to 1998. And what you can see here is that the NIH budget has actually been decreasing. There's a minor increase in the last year, but in real terms of spending, there's been a huge decline in the power of the NIH research dollar over the last decade or so. And this is a challenge that we have to deal with. And unfortunately, there are many things that we would like to do that we just don't have the fiscal resources to do. So we're very interested in gaining efficiencies, some of which we can do through networks. But sometimes we have to make very difficult decisions to fund one project and not another. There are a large number of areas that can impact cholestatic liver diseases. We've heard a lot about the genetics, certainly the biology of cells, regeneration of regenerative medicine, and a whole host of other things. All have potential impact in cholestatic liver disease, and all of these things are worthy of study and to a greater or lesser extent make up parts of our research portfolio. The challenge, and David alluded to this, is that many of the childhood liver diseases, including Alagille syndrome, are exceedingly rare. And it is difficult, if not impossible, to do meaningful research at single centers because you just don't have the volume of patients, nor do you have necessarily the critical mass of investigators to really move the field ahead. So this was recognized in the early part of the century, and it was felt that it would be appropriate to develop a network to really try to make progress in many of these childhood diseases. As I don't have to tell this group, but the cholestatic diseases tend to be rare. They have huge impacts on individuals and families. They are leading indications for liver transplantation, which is generally something that we prefer to avoid. And the therapies for these diseases, certainly in 2001, were virtually non-existent. So in June of 2001, we published, I wasn't there, but something called a request for applications. Basically, a funding announcement went out to the research community, and applications were reviewed through our peer review process, and 9 clinical pediatric transplant sites and a data coordinating center were funded to do research primarily in biliary atresia, but also to some lesser extent in other cholestatic diseases. And this was initially funded through the NIDDK as well as the NIH Office of Rare Diseases. Around the same time, another consortium was funded, which was called CLIC, the Cholestatic Liver Disease Consortium. These conveniently involved the same sites as BARC. The funding sites were the same. The funding sources were the same, and they were included as part of something called the Rare Disease Clinical Research Network, which continues to exist. And in 2009, BARC and CLIC got together and had children. In 2009, the network was renewed then as the Childhood Liver Disease Research and Education Network, and has been funded continually since then, and was just recompeted in the past few months. And we have funding secured that'll get us now through 2019. Despite the decrease in the overall NIH budget, we've actually been able to maintain our funding, and there's $6.5 million a year of NIH money that goes into that. Additionally, we have a large number of additional foundations and patient advocacy groups which participate in children, some of which also make monetary contributions. There are, going forward, 12 clinical sites and a data coordinating center at the University of Michigan, and these are the sites involved in children. We have reasonable coverage across the geography of the U.S. And really, it's despite the fact that we're spread out, we all talk to each other on a weekly basis. We meet 3 or 4 times a year in person. There are a large number of subcommittees involving all of the networks, and it's an extremely collaborative and very productive group. The diseases that the Children Network studies include biliary atresia, Alagille syndrome, neonatal hepatitis, bile acid synthesis defects, alpha-1 antitrypsin deficiency, mitochondrial diseases, other cholestatic diseases that are more rare, and the effects of cystic fibrosis on the liver as well. And the main study that involves patients and families with Alagille syndrome is LOGIC, which is the longitudinal study of genetic causes of intrahepatic cholestasis. And this study, this is a database where I'm sure many of your kids are enrolled in Logic through the Children Network. But the diseases that are studied and followed are Alagille syndrome, alpha-1 antitrypsin, progressive familial intrahepatic cholestasis, and benign recurrent intrahepatic cholestasis. But these two, alpha-1 antitrypsin and Alagille, make up the large majority of patients in the network. It has been enrolling since 2007, and this number is actually not current. It's a little bit higher than that, but there are over 850 subjects enrolled, over 265 of whom have Alagille syndrome. And among the things that are being studied are the genetics through collaborations with Dr. Spinner, who was mentioned, and others, natural history, the bone disease, bone density, and pathology of these various diseases. Children has been very productive and very successful as a network. There are 37 full manuscripts that have been published by the network. There are quite a few more that are in various stages of preparation, and both at the American and the international liver meetings, the vast majority or a substantial part of the research that is presented in these diseases comes from the Children Network, particularly clinical studies. There have been a large number of ancillary studies, so these are studies that are not central to the network, but these are proposals that individuals either within the network or outside the network make to use the resources of the network to kind of further the research productivity. And there are a number of ancillary studies that are ongoing, and at least two of which are related to Alagille disease, or Alagille syndrome. What the network has accomplished is that it's defined many of these diseases, their outcomes, their natural history, in a way where there are enough patients and enough power to really be able to make very solid conclusions as to what actually happens in these diseases, and be able to give families and patients reasonable predictions of what to expect upon diagnosis. We have a huge repository of tissues and DNA that's available to the network and to people outside the network. The key to the network, the key to all of our collaborative networks is really the collaboration, the fact that you have teams of really the leading scientists, leading physicians in these areas working together, trading ideas with each other, using the expertise and the technical ability and labs of each other to really do far, far more than any individual could do on their own with their own limited number of patients. And we also provide a platform and an infrastructure for clinical trials. Major trial in biliary atresia was just published, but we're about to embark in our first clinical trials in Alagille syndrome, and some of you may have heard of this. The ITCH trial is looking at the use of a bile acid reuptake inhibitor in reducing itching in Alagille syndrome, and I think that's something that will be of tremendous value to the community if it turns out to be fruitful and successful. And then there's an extension study, and this is being done through a public-private partnership along with a pharmaceutical partner, Lumina, which is now part of a bigger company called Shire. And I believe that Sierra Kennedy is going to be here tomorrow to discuss that, and she's the Vice President of Cholestatic Diseases for Shire. just like to finish by thanking all of the centers and participants in the network, the clinical sites, the primary investigators, the co-investigators, the study coordinators, often nurses, who are invaluable in doing this and really are the interface between you and the network, surgeons, pathologists, and all who were involved in the Children Network, the Data Coordinating Center at the University of Michigan, and the people on our team at the NIDDK who do a lot of the work and a lot of the coordination, especially Becky Torrance and Sherry Brown, who are clinical trial specialists and are very important in administering the network. We have a technology transfer lawyer who is very important in facilitating these interactions with various industry partners, pharmaceutical, diagnostic firms. Catherine Carr, who's our regulatory specialist that does all the grunt work that allows the clinical trials to take place. And my bosses, Jay Hufnagel, who heads the liver disease research branch, Steve James, who is the director of the digestive diseases and nutrition branch, and Griff Rogers, who is the director of NIDDK. And it's really these people that make the decisions that allow us to fund networks such as Children. And very importantly, the contribution of patient advocacy and support groups. Cindy, as an example, is actually on our patient advocacy group subcommittee that meets regularly and advises the network. And additionally, Cindy has recently been named to the advisory council of NIDDK. So, she, as well as doing all she does for you, does a lot to help us as well. And most importantly, I want to thank the families and the children who participate in our trials, and really without you, we're nothing. So that's all I have to say. If there are questions, I'm happy to answer them. If not, have a great weekend.
How are we doing on time? Okay, so we got about 10 minutes. If anyone had questions for either Dr. Piccoli or for Dr. Shirker, we could entertain those questions for a few minutes. I do want to reserve about 2 at the end for a couple other announcements. But did anybody have a question that you wanted to pose to us? Yes, raise your hand. No one has any questions. Are you sure? Okay, we've probably totally overwhelmed you. So think about it overnight, and then you can ask us a bunch of questions tomorrow. We do have childcare pickup, I guess, in the next few minutes. We have our life celebration out on the patio at 8:30, and someone chats tonight. I would encourage you, if you have not enrolled in the Children Longitudinal Study in Logic, to grab one of the board members, and we can get you information about that study. We have about 280 or so kids in that study already. We're shooting for 400. So any and all that are interested. All right, use the microphone. So any and all interested in the longitudinal study, please let us know, and we will connect you with the institution that's closest to you. The other thing is that the Alliance also has a patient registry, and there's a brochure about it in each of your portfolios, and I would encourage you to go online and enroll in the registry. What that does is it helps us locate people that have Alagille syndrome, and it also lets us tell you about studies that are upcoming, and just to kind of keep you abreast of research. So the questionnaire that's on there right now, it takes you about 10 minutes to go through it and answer the questions. And we'd really appreciate if people would enroll in that. I think we have over 100, I guess, that are on there as of now, but we're trying to find everyone that has Alagille syndrome. So, and then tomorrow's program, we get started at 8:30 with welcome and introductions back here in the ballroom. If you're staying here in the hotel, breakfast is complimentary, and it starts at 7 on weekends. So you can grab something to eat before you get over here. Did you have something, Elena, or you just, what? Oh, yes. We were not able to put the photo release together before we put the portfolios together. So if Patty or one of the other board members has not grabbed you to have you sign a photo release, please see one of us and we can do that. Because we are both live webcasting the symposium on our YouTube site, as well as taking a bunch of pictures, and we want to make sure that we have your permission to do that. And with that, I think we can let you go to grab the kids and come on back down. Thanks.